So yesterday we looked at the like note stuff to go with 3.8. So today we will be working on some problems. Okay, we're going to do the inverse of the 2x2s by hand, and then we'll work some other problems, and I'll show you how to find the solution of a system on your calculator. So we're going to start out finding inverses. So stuff like 3 through 10. We'll start with number 4. Okay, so we're given -2, 3, -3, 4. And we want to find the inverse of that. Okay, so to do that, we do 1 over the determinant of this. Okay, so we need to find the determinant of that. So it's going to be 1 over, what's the determinant of this matrix? So it's -8 minus a -9. So it's +9. So that is going to end up being negative, or no, it's going to end up being 1. But then we multiply it by, okay, remember we flip these two. So we write 4 in the top corner, -2 in the bottom corner. And then we change the signs on this other diagonal. So it's going to be -3 here and 3 here. Okay, now don't get confused when you go back and look at this example and be like, oh, we flipped these as well. Okay, we flipped the sign on them is what happened there. So just make sure you're careful with that. So this is just going to be 1 times this matrix. Okay, so your answer is just this matrix here. Yeah. If it was something other than a 1, we'd actually multiply it through. Okay, and if we wanted to check to verify that that's the inverse, there's a couple things. A, we can put it in our calculator and hit the inverse button and check. B, we can multiply this times this, and it would give us the 1, 0, 0, 1 thing that we looked at yesterday, the identity matrix. Okay, so those are 2 options to check it, but we'll get into that in a minute. I just want to do some of these by hand first, and then we'll go back and check some of them. So let's do number 6. So we have -7, -9, 2, and 3. So I need 1 over the determinant of this matrix. So what is the determinant? Okay, so that times this matrix, which is, just copy it down, or no, you don't copy it down. What do I do? Yeah. 3, 9, -2, -7. Okay, so you flip these two, change the sign on these two. Okay, so I end up with then, try to write this a little neater, 1 over -3, and then 3, 9, -2, -7. So when I multiply through, what do I get? Well, you're multiplying 1 over -3 by that. Basically dividing by 3. Make sure you have the sign with it, negative. Yeah. And then you're done. Okay, you don't have to do anything. Once you get the fractions, you're done. Okay, obviously they won't always be fractions. Alright, so I want you guys to try this next one on your own paper. 6, This is negative 22, negative 12, and 20. Okay, so I want everyone working this problem. Because it's 1 over the determinant of your original matrix. All right, everybody should be doing this on paper. You're going to be doing participation grades if you're not. No, not right now. Just divide it. Set them up as fractions and then reduce them. I'll give you about 30 more seconds. Yeah. All right, what do we get? Yep. Okay, so the determinant of that original matrix was 120 minus 264. Okay, so that gave you a negative 144. Okay, then the matrix obviously modified to be what it's supposed to, multiplying everything by 1 over negative 144. You just have to reduce stuff, so I just wrote my fractions out over here and just started pulling stuff out until I narrowed it down. And then that should be the answer you got for that one. Alright, so then let's check this on our calculator. So you're going to go input this matrix in. No, your original. Alright, so once you do that, you're going to do second matrix, put in the matrix that you just put it in. And then the matrix button, actually, the button that you click to get matrix, actually, it has a glare on it right now, but it's actually x to the negative 1 is the button you click. You're going to hit that. So it's going to do the matrix, and that means inverse. Okay. So math, and then hit the math button. Then this one that's the, I would say dark frac. I don't know what it means, or what it is, but it should change it to fractions for you. And then it will verify for you that you did it correctly. Okay. Alright, so then let's do the inverse of a 3 by 3. No. It's too much work. 20, 102, 213, 144. No, these ones actually say to use a calculator. And then once we do it, we'll verify that it's the identity matrix after we do that. So when you, obviously if you're putting one in your calculator, okay, you're going to do the matrix, and then you're going to do the negative 1, so that way I know that you put it in your calculator, like that. Okay. So I'm just going to type that matrix in, and it's going to give me a inverse matrix. So go to second matrix and type that in. I would prefer fractions. No. It would take you way too long. Because there's a lot you have to do. Because, like, obviously with the 2 by 2, like, yes, you could find the determinants. You could get 1 over the determinant pretty easily. But then the hard part would be of the way that you have to shift things within a 3 by 3 to get it. 'Cause like the other one, we flip top, left, bottom, right, and then we change the signs of top, right, bottom, left. But with this, It's just, there's too many moving pieces. All right. Everybody get this when they put it in their calculator? Making sure everybody's calculator's working. All right. So do we need to do another one since you're doing it on your calculator? Okay, so really quick, let me just show you how to verify that these are inverses. Okay, basically we're going to be multiplying these two together. Okay, so let me verify. I'm pretty sure. Yeah, okay. So, hold on a second. Let me get this back up. So keep your matrix up that you just had on your calculator. I said just keep it up on your calculator because I'm going to show you what you're going to do to store this so you can check that it is an inverse. Okay, so you have to check that matrix A times A inverse is equal to the identity matrix, and then you have to check the reverse, that A inverse times the matrix A is equal to the identity. Okay, if they're not equal to the identity, something is wrong. Okay, so hopefully your calculator didn't make a mistake. Okay, and I may ask you to do this with a 2 by 2 as well, but if I ask you to do that, I will give you your calculator so you don't actually have to multiply them out by hand. Okay, you'll be checking them with your calculator. So, what you're going to do, this button down here that says STO, that means store. So we're going to click that. So we're going to store the answer, this matrix. You're going to go to second matrix. Obviously, you have your original matrix in A, so don't put it there. Put it in B. Okay, so your thing should look like this. Okay, and then when you do that and you hit enter, now matrix B is this matrix. Okay, so you hit this store button here after you have your, whatever you got for your inverse, hit the store button, and then go to second matrix, put it in obviously a different matrix, so in this case for me it was B because I used A for my original. Okay, so now when I want to check and verify that this statement is true, okay, I'm going to go to second matrix A, second matrix B, and I got out the identity matrix. Okay, so what you need to write here is you would need to show me that this came out to be 1 0 0 0 1 0 0 0 1. You have this stored, right? Okay, you just type in A times B, and then it'll give you out the identity if your stuff was truly inverses. Okay, so then now you need to do the reverse. You need to do B times A. And that also gave me the identity. Okay, and I'll be looking for you to actually write this out, okay, on your test. If it doesn't, that means go back and redo it because something is wrong. Okay. Now, that's more so for the 2 by 2 because 3 by 3, if you're doing them on your calculator, you shouldn't really have a problem. But you never know. All right. So you all ready for me to make your lives easier and show you how to solve a 3 by 3 without actually having to do it by hand? All right. So 36. We have negative 3x plus y minus 8z is equal to 18. We have x minus 2y plus z is equal to negative 11. And 2x minus 2y plus 5z is equal to negative 17. Okay, now obviously you could do this by hand. Okay, you could cancel the y's out. It would be pretty easy to cancel those. Okay, and you could do this by hand. And that might be bonus on whatever section I give you this one and say, okay, do this on your calculator using matrices. Then I might say, also if you choose to do it by hand, you get some bonus points too. Okay, kind of like I did with the checking the determinant, stuff like that, or the multiplying. Huh? Are you talking about on the calculator page? I mean, it didn't really matter which way you did first, but it was technically, you had to do the calculator part. The other part was extra credit. Alright, so we're literally going to copy the numbers down here. Okay, we're going to end up with a 3 by 4 matrix. Okay, so you're going to copy them down. So it's going to be -3, 1, -8, 18, 1, -2, 1, -11, 2, -2, 5, -17. Okay, and I'm going to tell you, it won't be like optional to just do it by hand. Like, you're going to have to do it on your calculator. Okay, you're going to have to set up the matrix like this. You're going to have to tell me what you're putting in your calculator, stuff like that, okay, for these problems. The numbers in front of the variables. You just copy them down. So this is your X column, this is your Y column, this is your Z column, and this is your answer column. Okay? So type this into your calculator. Yep. Okay, and I'm just going to tell you, you can use inverse matrices to solve these equations, but I think that's harder, so that's why I'm teaching you this way. I'd rather you just do it this way rather than using the inverse. Okay, everybody have it typed in? Okay, so we're going to be looking for a function called RREF. Okay? This is row reduced echelon form. Okay, you don't have to know that. Just know that it's RREF. So you're going to do a second matrix. You're going to go over to math. You're going down to the 1, and you have to be careful. There's an REF, and then there's an RREF. You have to have the RREF one. Okay? Just go down. It should be letter B. Okay, once you have that, you're going to go put in the matrix. And then hit enter. Okay, so then you're going to write this down, and then I'm going to tell you what this means. So I would want to see, after you do this, I would want you to write down what you got, and then I'll show you how to interpret it. Okay, so this is how I expect it to be written on the test. Hold on, I'm going to explain it in a minute. Yeah, it's a -2. I'll tell you why in a second. You don't have to have them. I'll just tell you in a second where they come from. Okay, so basically you don't have to have these dots here. Basically this is just separating like your problem statement from your solutions. So it's just like, I don't know, I was always taught just to put them, just to kind of like separate. Technically I could have put them up here too. Okay, it just kind of helps you just like visualize more what's going on. That's basically where the equal sign was in your original equation. Okay, so I told you that this column is the X column. So the way we read this, okay, there's an X here, there's no Y, there's no Z, sorry, in this row. There's no X, there's an X, there's no Y, there's no Z, so X is equal to -2. Okay? In this row, there's no X, there's a Y, there's no Z, so Y is equal to 4. Bottom row, there's no X, there's no Y, but there's a Z, so Z is equal to -1. I'm just going to tell you, in college, I had to do this by hand. To get from here to here, by hand. It's not fun. You multiply rows by things, you divide them by things, you add them, you switch rows. It's awful. Yeah, by hand. Great question. If I have a calculator to do it, I'm doing it with my calculator. So, that's why I'm teaching you with your calculator, because you would literally hate me if I made you do it by hand. Okay? So, remember, when we solve this, our answer has to be written as an ordered triple, so you have to rewrite it like so. So basically, this is your x column, y column, z column. So wherever the 1 is, that's the variable that represents. And it's always going to look like this. Like you're always going to have 1s on the diagonal. So your top row is always going to be your x value. Your middle value is always going to be your y value. And the bottom one's always going to be your z value. These are always going to be 1, so you won't have to do anything with them. Yep. And then you have to write it as an ordered triple, because that's the official solution to the problem. All right. Let's do one more, and then I'm going to give you guys some problems to work on. All right, I'm going to just try to fit it right here. All right, 40. 6x plus y plus 2z is equal to 11. Also, really quick, if any of these values were 0 or it was missing, like let's say this negative 2y was completely missing, so I just had x plus z is equal to negative 11, you still have to put a 0 in for that spot. Okay, you can't just ignore it. You have to put a 0 in to fill it as a placeholder. Okay, so then this one over here, x minus y plus z is equal to negative 5. Then negative x plus 4y minus z is equal to 14. All right, so somebody tell me what my matrix should be. Okay, so now I'll go put that in your calculator. Okay, and then do the RREF of that matrix. All right, what do we get? Read across the matrix for me. Okay. So what does this mean? Yeah, so you can just write that. Okay, you don't have to write this out. I was just writing this over here for the first one to show you guys what this means. But once you do this, you can just copy it down in order to an order triple. Okay, I'll let you guys save a little bit of writing on that. Any questions about how to do these? Okay, so notice that these problems, 35 through 40, are going to say to use an inverse matrix to do this. Are you doing it that way? No, you're doing it this way. Okay, so you're doing the modified method. Okay, so let me give you your problems. Huh? Yeah. 5, 7, 19, 35, and 39. Okay, so these three here are all calculator problems. Okay, so 5 and 7 are the only ones you have to do by hand. If you want to check it with your calculator, you can, but you have to do 5 and 7 by hand. And then the rest of them are on the calculator. So I know we don't have as much time as normal. Okay, we only have about 18 minutes, but I felt like doing examples was more important, so